Hello and welcome to the flipped instructional recording for the start of Unit 2. Today's lesson is 2.01 Energy. So remember, as we get started, if you struggle with taking notes during the lessons, be sure to write down the things that I mention as I read through. I'll be covering all the guiding questions as well, so be sure to jot down those answers. And don't forget, you want to create a slide or a page in your notebook for each lesson that you work through. So as we get started in lesson 1 of each unit, you are going to want to start a new notebook for every unit. And so this will be your Unit 2 notebook. And lesson 1 is always a little bit long. There's a couple of extra things in there. So this recording is just a little bit longer. Don't forget to answer your essential questions. Kind of goes over the basic things that you're wanting to get out of the unit. So first, or what are the different forms of energy and how can energy change from one form to another? So you can write these on a separate slide if you want, just make them your first slide. If you use the templates that I've already created for you under content, you'll see them there already. And then, so question 1, where does your energy come from? And 2, when you use energy, where does it go? So do you use it all up or does it just disappear? All right, so if we get started into figuring out what is energy, energy is part of your daily life. Without even realizing it, you have felt it and observed its effects. Consider a day at the beach. The heat from the sun, the crash of the waves, and the breeze off the water are all examples of energy. But what is energy? In this lesson, you will learn how energy is defined in scientific terms, explore different forms of energy, and learn how these forms are a part of everyday life. So you've got a graphic organizer. These are always helpful in organizing the thoughts and things that you should be getting out of the lesson. They are not required to be submitted, but I do encourage you to use them. The science notebook template, if you are doing your own template and not using the one I created, remember this is where you'll want to open your first PowerPoint file, and then you'll want to add slides to the file at the end. So as you go along, actually. And here are your lesson goals. And the first, this is the keywords for the unit. So you don't need all of those right now. And then you'll notice there are a lot more guiding questions out of each unit and lesson this time than as opposed to last semester. So again, I'm just going to open up a Word document and move this over to the side. I like to do a screenshot of the guiding questions so that we make sure we get all of those answered as we go through and read. And remember, they are in order as you read, so it is very easy to answer those. So the first question we're looking for is, how is energy defined scientifically? And so here it is in the first sentence. The word energy is used in a variety of ways. When you're tired, you might say that you don't have any energy, but how do scientists define energy? Energy is defined as the ability to do work. So if you click on this, the ability or capacity to do work, and then here you're understanding what the definition of work is. That's using an applied force to make an object move. So I would go ahead and write down those two definitions as part of your notes. So with energy, changes in the physical world are possible. These can be a change in speed, a change in direction, a change from cold to hot, and many other kinds of changes. For example, the white cue ball in this image has energy because it's moving. It does work by making the other billiard balls move. They change from being at rest to moving across the table in different directions. Once they are in motion, they possess energy that came from the cue ball. So let's look at this little picture, a little Greek. So it's telling you the word energy comes from the Greek word en, which means at, and ergon, which means work. So at work. And again, we're just looking at that picture. So we have number one, the definition of energy. The guiding question has been answered. And now number two says, what are the three forms of energy, and give an example of each. So we can see these right here on the screen. It says you encounter different kinds of energy every day. Some forms of energy include mechanical, chemical, electrical, sound, light, and nuclear. Take a look at mechanical energy first. Mechanical energy is the energy due to motion and position, and it is the combination of two forms of energy, kinetic and potential energy. So you remember those from Unit 1. These cyclists are demonstrating mechanical energy. They push on the bicycle pedals using the potential energy stored in their muscles to make the bicycle go faster, increasing the kinetic energy of the bicycle. What is another type of mechanical energy? So water moving a turbine to produce electrical power is an example of mechanical energy. So pretty much mechanical is anytime that you see something moving. So three forms of energy are written up here. For your guiding question 2, you've got mechanical, chemical, electrical, sound, light, and nuclear. So it just says to list 3 of those and give an example of each. Okay, as we move on, we're talking about chemical energy now, which is guiding question 3. And it says it takes a different form of energy to warm a house and to make a vehicle run. Chemical energy does this through the energy stored in chemical bonds. For example, you use natural gas to heat your home and to fuel a cooking stove. Burning natural gas creates a chemical reaction and changes chemical energy into heat and light. The reaction breaks chemical bonds in the natural gas and forms new compounds that have new chemical bonds. Chemical energy is also released when fireworks explode or when gasoline, coal, or propane are used to fuel engines and furnaces. So how is chemical energy stored? And the answer here, it is stored in bonds between atoms. When these bonds are broken, the energy is released. So a couple of things that you need off of this page. 1, the definition of chemical energy. And 2, I would include how it is stored in your notes. So here we're looking at the chemical energy stored in gasoline is released when the gasoline is burned in the car's engine. And then taking notes, it says, as you record your notes for this lesson, keep in mind the central themes of the lesson. Make sure you list the different types of energy discussed in this lesson, along with examples of each type. And remember to include all your vocabulary words. All right, so that answers what is chemical energy. So guiding question 3 is answered. And question 4 says, what are sound and light energy? And then number 5 is, what is electrical energy? So electrical energy is associated with electric charges. It can be sent along wires because of the way electrons move within the wire, exert forces, and transfer energy. Electrical energy is used to light homes, schools, and businesses, and to power appliances. How is electrical different from chemical energy? So we can see here, this is a great thing to include in your notes. Electrical energy is energy due to the movement of electrons or electrical charges. Chemical energy is energy stored in chemical bonds of a substance. So you can see here you have a hydroelectric power plant. It produces and distributes electricity to its customers, and it's hydro. We know that it has something to do with water. So that answers question number 5. And then it looks like these were just out of order a little bit. So now we go back to question 4. What are sound and light energy? So if you place your fingers on the front of your neck and read this sentence out loud, what do you feel? When you speak, your vocal cords vibrate, and you can feel vibrations when you touch your neck. The vibration of your vocal cords creates sound energy. So sound energy is energy produced when matter vibrates. Let's see, you can also feel vibrations of sound energy when you're in a room with loud music playing. So the difference here, moving to light energy, it is a form of electromagnetic energy. It is the vibration of electrically charged particles that send light energy out into the space around them. All right, so here's your definition that you want in your notes. A form of electromagnetic energy, the vibration of electrically charged particles. So when light energy is transmitted into our eyes, it causes signals to be produced in the nerve cells at the back of the eye. The brain then interprets these signals, allowing you to see them. And as you guys have maybe seen so far, you can find some content in here that you need for quiz questions. So let's take a look. When you talk on the phone, your vocal cords vibrate and create sound energy. Sound energy created by very loud music can be felt through the vibration of the floor. And finally, light energy transmitted into your eyes creates signals that our brains interpret, allowing us to see. So you now have the answer to number 4, sound and light energy, and we're ready to go on. Question 6 says, what is nuclear energy? So nuclear energy is energy released by changes in the nucleus of an atom. In a nuclear power plant such as this one, nuclear energy is created when nuclei of atoms of elements like uranium and plutonium are split using nuclear fission. So that's a very important sentence. Nuclear energy, how it's created. So you need not only the definition, but how it's created. You need to know that too. So the splitting of the nuclei releases large amounts of energy. A nuclear power plant uses nuclear energy to generate electrical energy. Nuclear energy is exhibited by the sun, and in this case, the nuclei of atoms of elements like helium and oxygen helium and hydrogen are combined in a process called nuclear fusion. So we need to know the difference in fission, right, where we're using uranium and plutonium, and then nuclear fusion, you've got the nuclei of the atoms of the elements helium and hydrogen are combined. So you can remember the word fuse. That means the elements are combined. And when two smaller nuclei combine, they release larger amounts of energy. Okay, so make sure you have fission up here where they're split and fusion where the atoms are combined. So make sure you know that difference. And then Otto Hahn, the splitting of an atomic nucleus was first observed by a German scientist, Otto Hahn, in 1938. Because of his work with nuclear fission, he was awarded the Nobel Prize for Chemistry in 1944. And so here's a picture of a nuclear power plant, and that it talks about nuclear energy is used to create or generate electric energy. So you could write that down in your notes as well. So that answers number 6. So now we're going to number 7. What is the law of conservation of energy? Another important feature of energy is stated in the law of conservation of energy. This law states that energy can neither be created nor destroyed, but it is transformed. This means energy can be transformed from place to place and can also be converted between different forms of energy. Whether transformed or converted, the amount of energy is always conserved. It cannot be created or destroyed. So remember this law, you need to have it in your notes. It's a lot like the law of conservation of matter we learned about in semester A. So a good example of energy conversion is seen in a flashlight battery. When a flashlight is turned on, the chemical energy stored in the battery is transferred to the light bulb, producing light energy. In this case, energy has not been created or destroyed, it has been transferred. So this is an easy example of something that you could draw into your notes. If you're an artist type person, you're pretty artsy, you can draw. Feel free to draw that flashlight, the battery, use some arrows to describe the energy transferring. If you just want to write the words out and use some arrows, battery, flashlight, light energy, Just make sure you understand that, and it's a great thing to have in your notes as well. And it also sums it up here again. When a battery is used in a flashlight, the chemical energy in the battery is converted to light energy. So that gets number 7. And how is energy transformed? All right, so let's look. Again, here are your types of energy. So you definitely want to have those in your notes as well. And if you are able to get all of these words matched in the correct spot, you could take a screenshot of this and put it in your notes as well. All right, so moving on, question 8 says, how is energy transformed? Take a closer look at the law of conservation of energy. Suppose you are in a closed physical system in which no energy enters or leaves. With you is a bell that has a rope tied to its clapper. You grab the rope and ring the bell. Watch this animation to see how the energy is conserved. All right, so looking at the picture, chemical energy in your muscles, you've got the heat of the bell, the motion of the bell, sound, heat of the arm, motion of the arm. All right, so within this system, energy does not increase or decrease. Muscles provide chemical energy to make the bell clang. The amount of chemical energy in the muscles is used to kinetic heat, and the sound energies that result when the bell rings. Energy is transformed to different forms, but the total amount of energy in the system remains the same. All right, so it's saying all of those things can transform, but you have not added any energy into this system. All right, so how is energy transformed? Basically, it just changes form. Okay, so the energy does not increase or decrease. If you read the amount of energy, chemical energy in the muscles used is equal to the kinetic heat and the sound energies that result. So it's transformed to different forms is what your answer is. All right, and then question 9, what are some examples of energy transformations? So we just gave that example, but let's look here as well. What are some other examples of energy transformations? Gasoline contains chemical energy. When it's burned, it's transformed into heat energy and mechanical energy, which is needed to make vehicles move. So there's a good example. Although the form of energy changes, no energy is created or destroyed. In another example, electrical energy is used to power radio speakers. The speakers work by transforming electrical energy into sound energy. Sound energy causes your eardrums to vibrate and enables you to hear the music. Again, energy is not gained or lost, but it changes form. Look at these images to see other examples of energy transformations. So you can use some of these examples in your answer as well. So this would be question 9. Burning wood converts chemical energy to heat energy. Nuclear reactors convert nuclear energy to electrical energy. Sails on ships capture wind energy and convert it to mechanical energy. A battery stores chemical energy, which is converted to electrical energy. So you have all of those examples as well. So sources of energy, and that's guiding question number 10. It says energy is obtained from a number of sources. Energy resources can be categorized as either renewable or non-renewable. So in your notes, I would put the title, sources of energy, and then I would kind of break those off and diagram it out to renewable and non-renewable. And then you'll be able to bullet point list your facts about each underneath. So a renewable energy resource is one that can be replaced. And then list your examples in. This is where you could draw a picture in if you wanted. Sunlight, wind, moving water, wood, those are all examples of renewable energy resources. A non-renewable energy source is one that can't be replaced. Oil, natural gas, coal, and uranium are examples of non-renewable resources. What kind of energy is geothermal energy? So if you think about geothermal, right? Geo talking about the earth and the geography, and then thermal. It means natural heat from the earth that's found in natural hot springs, and that is a renewable energy source. It is clean and it is sustainable. So geothermal, you might write that down if you did not know what that word means. And so here's a couple of things, some more pictures just to show you that sunlight is a renewable resource. Solar cells like these gather energy without using up the sun. Coal is a non-renewable resource. Once the coal supply is used, it will take millions of years to replenish. All right, so that answers number 10, and we just have number 11. How do you measure energy? So energy can be measured using the SI unit called a joule. Okay, so you have, I would write out the word and the abbreviation. It is a capital J. So make sure you know it is the SI unit that measures energy. 1 joule of energy is used when a force of 1 Newton is applied over a distance of 1 meter. So it is important to kind of write out that formula. As you saw in the last unit, it's you've got to understand kind of when those are put into fractions, our brain, it's a little bit more difficult to process that. So if you have it written out that the joule is used when you're talking about the force, and that 1 Newton is applied over the distance of a meter. So a Newton meter unit of work, they found that term to be kind of cumbersome, Newton meter, so then they created joule. So 1 joule is equal to 1 Newton meter, if you hear that. And Newton we know is force, and meter we know is distance. So see if you can apply this concept to a real life example. Look at this image of a mother pushing her daughter inside a box. If she pushes her for 1 meter with a force of 1 Newton, then the girl's mother will have used 1 joule of energy to complete the task. So the joule is the unit of energy as well as the unit of work. And then it says, say what? So the unit name Joule honors the English physicist James Prescott Joule. People are accustomed to pronouncing this word as Joule, but Joule and his family pronounced it jowl, like owl. So that's interesting. And so this just shows you again kind of how that concept of what a joule actually is. And that answers question number 11. So you got another word bank to fill in. These are always great, making sure you understand all the concepts. You can screenshot that and have it in your notes as well. So we have gone through lesson 1, and it is long. We're about 22 minutes in. So thank you so much for listening to that part. In the lesson, you learned about the relationship between energy and work, and you also learned about the different forms of energy, and you were introduced to how the law of conservation of energy proves energy is not lost or gained, but is transformed. So you can answer the following questions just to kind of review, make sure you understand that, and you will be all set finishing up with lesson 1. So finally, as we wrap up, our slide left, just make sure, we'll go here again, look for the flip follow-up session in your Class Connect calendar. If you have questions, come see me in Help Lab, and have a great day.